Python is a powerful, versatile programming language used in a wide range of applications, from web development to data science and more. Now, let's set up our coding environment. Head over to the official Python website and download the latest version. Once installed, you can choose an integrated development environment, or IDE, that suits you. Popular options include PyCharm, Visual Studio Code, or Jupyter Notebook. I have uploaded a full video about how to download Python and PyCharm in this channel. Please check that out for more clarification about it. Links are in the description. Now let's write our first line of code, the classic "Hello World" program. It's a tradition in programming to start with this simple output. Type in a few lines of code and watch as your computer responds with that familiar message. What is a variable? Think of a variable as a container that holds information. Just like a box that can hold different items, a variable in Python can hold different types of data, like numbers, text, or even more complex data types. Here's a simple example. See? Age is a variable holding the number 25, and name is a variable holding the text Alice. Variables are super useful because they let us store and work with data easily. Naming conventions and best practices. Now that we know what variables are, let's talk about how to name them properly. Think of variable names like naming a pet. You want something meaningful and easy to remember? Here's the deal. 1. Use descriptive names: age, total score, username. 2. Stick to lowercase with underscores. 3. Start with a letter or an underscore, but never a number. 4. Avoid using Python reserved words like class, for, if, etc. Remember, naming your variable X might seem cool, but naming it number of apples makes your code so much more readable. Numbers and basic arithmetic operations. Now, let's talk numbers. Python can handle all sorts of number-related operations. From basic math to more complex calculations, Python's got you covered. Let's do some quick math. Easy peasy, right? Plus, you can do exponentiation with 2 stars and modulus with percentile symbol. Python makes math fun. Next up, strings. Think of strings as a way to work with text. Anything inside quotes, single or double, is a string. Check this out. Simple, right? But wait, there's more. Python has tons of built-in string methods to manipulate text. You can convert cases, replace parts of strings, split them, and so much more. String manipulation is incredibly powerful and super fun to experiment with. Think of a list as a collection of items, like a shopping list. You can store multiple pieces of data in one list. Here's how you create a list. Here's a simple example. Easy, right? Now, let's add items to our list and remove some too. Check this out. Accessing list elements. Now that we have a list, let's learn how to access its elements. Each item in a list has an index, starting from 0. Here's how you can do it. You can also change items in the list using their index. Lists are super versatile and great for keeping track of collections of items. Next up, tuples. Tuples are like lists, but with one key difference: they are immutable, meaning once you create a tuple, you can't change it. Since tuples are immutable, you can't add or remove items, but you can access them just like lists. Check this out. Tuples are great for data that you don't want to change. They are used for fixed collections of items. What are conditional statements? Conditional statements allow your program to make decisions based on certain conditions. Think of them as the if this, then that logic in your code. They let you control the flow of your program by executing different blocks of code based on whether conditions are true or false. In Python, we use if, elif, and else to create conditional statements. Let's dive into each one. Here's a simple example. See how that works? The if statement checks a condition, and if it's true, the code block under it runs. If not, it moves to elif and finally else if none of the conditions are true. Comparisons and logical operators. Now, let's talk about comparisons and logical operators. They help us write more complex conditions. Here are some comparison operators. Logical operators combine multiple conditions, like this. Combining these operators allows us to make powerful decisions in our programs. Writing clean and efficient code. Now that we know how to use conditional statements and operators, let's focus on writing clean and efficient code. Here's how you can keep your code clean. Indentation. Proper indentation is crucial in Python as it defines the scope of your conditions. Avoiding nested conditions. Too many nested conditions can make your code hard to read. Try to flatten them when possible. Using Boolean variables, they can make your conditions clearer. Clean code is easier to read, debug, and maintain. And what are loops? Loops allow you to repeat a block of code multiple times. Instead of writing the same code over and over again, you can use a loop to execute a block of code as many times as needed. This makes your code more efficient and easier to manage. In Python, we have two main types of loops, while loops and for loops. Today, we are focusing on while loops. Let's dive in. Using while loops. A while loop lets you repeat a block of code as long as a condition is true. Here's a simple example. In this example, the loop runs as long as count is less than 5. Each time the loop runs, count is incremented by 1. Now, let's talk about loop control statements, break and continue. These statements give you more control over your loops. The break statement exits the loop when a certain condition is met. Here, the loop stops when count equals 5. The continue statement skips the rest of the code inside the loop for the current iteration and moves to the next iteration. In this example, only odd numbers are printed because continue skips the even numbers. Now, let's look at some practical examples of using while loops. Here's an example of a simple guessing game. This guessing game continues to prompt the user until they guess the correct number. It uses while, if, elif, and else to provide feedback on the guesses. Another example is summing numbers. Here, the loop continues to sum the numbers until the user enters 0. Unlike while loops that run until a condition is met, for loops iterate over a sequence, like a list or a string, and execute a block of code for each item in the sequence. Here's a simple example. In this example, the for loop iterates over each item in the numbers list and prints it out. Next, let's see how we can iterate through lists and strings using for loops. Here's how you can iterate through a list. And here's how you can iterate through a string. Using for loops, you can easily process each item in a list or each character in a string. Now, let's talk about nested loops and loop optimization. Nested loops are loops inside loops, which can be useful for working with multidimensional data structures. Here's an example of nested loops. In this example, the outer loop iterates over each row of the matrix, and the inner loop iterates over each item in the row. Loop optimization is important to keep your code efficient, especially when dealing with large data sets. Here are a few tips. Avoid unnecessary nested loops. Try to flatten loops if possible. Use built-in functions. Functions like range and list comprehensions can make your loops faster. Break early. Use break to exit loops early when you've found what you're looking for. Let's see an example of optimizing a loop with list comprehension. This is a more efficient way to create a list of squares compared to using a traditional for loop. And then in Python, dictionaries are a collection of key-value pairs. They are used to store data values like a map, which unlike other data types that hold only a single value as an element, hold key-value pairs. Each key in a dictionary must be unique. Here's an example of a dictionary. In this example, name, age, and major are keys, and their corresponding values are Alice, 25, and computer science. Think of it like a real-world dictionary where you look up a word and get its definition. Now, let's see how we can modify, access, and iterate through dictionaries. Here's how you can access and modify dictionary values. You can also add new key-value pairs. To iterate through a dictionary, you can use a for loop. This loop prints out each key-value pair in the dictionary. Now, let's move on to sets. A set is an unordered collection of unique elements. Sets are great for storing elements without duplicates and for performing mathematical set operations like union, intersection, and difference. Here's how you can create a set. If you try to add duplicate elements to a set, it won't change the set. You can also perform common set operations. Sets are powerful tools for managing unique items and performing set-based operations efficiently. Functions are blocks of code designed to perform a specific task. They help you organize your code and make it reusable. Here's how you can define and call a simple function in Python. In this example, we define a function called greet that prints hello, world, and then call it to execute the code inside the function. Functions make your code cleaner and easier to manage. Now, let's talk about parameters and return values. Parameters allow you to pass data to a function, making it more flexible. Here's an example with parameters. In this example, the greet function takes one parameter, name, and prints a personalized greeting. You can also have multiple parameters. The add function takes two parameters, adds them together, and returns the result. Using return allows the function to give back a value that can be used later in the code. Finally, let's discuss writing reusable and modular code. Functions help you avoid repetition and make your code more modular. Let's refactor some repetitive code into a function. By defining a calculate_area function, we avoid repeating the area calculation code and make our script cleaner and more modular. This approach is essential for maintaining and scaling your code base. Function scope and global variables. Scope refers to the region of the code where a variable is accessible. Here's an example. In this example, x is a global variable and accessible both inside and outside the function, while y is a local variable, accessible only within the function. Attempting to print y outside the function will result in an error. You can modify a global variable inside a function using the global keyword. By using global x, we can change the value of x globally from within the function. Now, let's talk about default arguments and keyword arguments. These make your functions more flexible and easier to use. Here's an example of a function with default arguments. In this example, the message parameter has a default value of hello. If you don't provide a value for message, it defaults to hello. You can also use keyword arguments to specify parameters by name. This way, you can provide arguments in any order, making your function calls more readable. Finally, let's explore lambda functions and the map, filter, and reduce functions. Lambda functions are small anonymous functions defined with the lambda keyword. Here's an example of a lambda function. Lambda functions are often used with higher order functions like map, filter, and reduce. Here's how you can use map to apply a function to a list. Use reduce to apply a function cumulatively to the items of a sequence. These functions can make your code more concise and readable when dealing with collections of data. Start with importing modules. Modules are files containing Python code that you can use in your own projects. They help you organize and reuse code efficiently. Here's how you can import and use a module. In this example, we import the math module and use its sqrt function to calculate the square root of 16. You can import specific functions from a module to save memory. You can also use an alias for a module or function to make it easier to reference. Now, let's explore Python Standard Library. It's a collection of modules and packages included with Python, offering a wide range of functionalities right out of the box. Here are some useful modules from the Standard Library. OS for interacting with the operating system, datetime for working with dates and times, random for generating random numbers. Let's see some examples. The Standard Library is extensive and incredibly powerful, so take some time to explore its modules and see how they can simplify your coding tasks. Finally, let's talk about installing and using third-party libraries with pip. Pip is a package manager for Python that allows you to install and manage additional libraries not included in the Standard Library. Here's how you can install a library using pip. After installing, you can use the library in your code. The requests library makes it easy to send HTTP requests and handle responses. There are thousands of libraries available on PyPI, the Python package index, to help you with almost any task. Basics of reading and writing text files. This is crucial for working with data stored in files. Here's how you can read from a text file. In this example, we use the open function to open a file in read mode, R. The with statement ensures the file is properly closed after its block of code is executed. Now, let's write to a text file. Here, we open the file in write mode, W. If the file doesn't exist, it will be created. If it does exist, its content will be overwritten. You can also append to a file without overwriting the existing content. Using append mode, you can add new content to the end of the file without erasing the existing data. Next, let's explore different file modes. Besides reading, R, writing, W, and appending, there are modes for working with binary files and more. Here's a quick overview of different file modes. R, read, default mode, file must exist. W, write, creates a new file or truncates an existing file. A, append, creates a new file or appends to an existing file. RB, read binary. WB, write binary. AB, append binary. R+, read and write, file must exist. W+, write and read, creates a new file or truncates an existing file. A+, append and read, creates a new file or appends to an existing file. Here's an example of reading and writing binary files. Binary modes are useful for handling non-text files, like images or executable files. Finally, let's talk about exception handling and error management. Proper error handling ensures your program can deal with unexpected situations gracefully. Here's how you can handle exceptions when working with files. In this example, we use a try block to attempt reading from a file. If the file doesn't exist, a file not found error is raised, and we handle it with an except block. You can catch multiple specific exceptions or a general one. You can also handle errors when writing to a file. Classes and objects. In Python, everything is an object, and classes are blueprints for creating objects. Here's how you can define a class and create an object from it. In this example, we define a class dog with a class attribute species and instance attributes name and age. The init method is a special method called a constructor that initializes the instance attributes. Now, let's add some behavior to our class by creating methods. Methods are functions defined inside a class that describe the behaviors of an object. Here's how you can add a method to our dog class. In this example, we added two methods, description and speak, to the dog class. These methods provide additional functionality to our objects. Finally, let's dive deeper into constructors and introduce the concept of inheritance. Inheritance allows one class to inherit attributes and methods from another class, promoting code reusability. Here's an example of a constructor and a class inheritance. In this example, the dog class inherits from the animal class. We use super.init to call the parent class constructor, ensuring the name and age attributes are initialized. The dog class also has an additional attribute breed and a method speak. Let's start with polymorphism and method overriding. Polymorphism allows objects of different classes to be treated as objects of a common superclass. It's a key concept in OOP that promotes flexibility and reusability. Here's an example of polymorphism and method overriding. In this example, both dog and cat classes override the speak method from the animal class. The animal_speak function demonstrates polymorphism by calling the speak method on different objects, producing different outputs based on the object type. Next up, we have encapsulation and access modifiers. Encapsulation is the concept of bundling data and methods that operate on that data within a single unit or class. Access modifiers control the visibility of class attributes and methods. Here's how you can use encapsulation and access modifiers. In this example, make is a public attribute, model is a protected attribute, and year is a private attribute. The setYear and getYear methods demonstrate how to access and modify the private attribute. Finally, let's discuss designing effective class hierarchies. A well-designed class hierarchy can make your code more organized, reusable, and easier to maintain. Here's an example of a class hierarchy. In this example, we have a base class vehicle and two derived classes, car and motorcycle. Each derived class inherits attributes and methods from the base class while also defining its own unique attributes and methods. This creates a clear and maintainable class hierarchy. Understanding what exceptions and errors are in Python. Exceptions are events that occur during the execution of a program that disrupts the normal flow of instructions. Here's an example of an exception. In this example, we attempt to divide 10 by 0, which raises a 0 division error. We use a try block to wrap around the code that might raise an exception, and an except block to handle specific exceptions gracefully. Next, let's explore the comprehensive handling of exceptions using different blocks, try, except, else, and finally. Here's how you can use all these blocks together. In this example, the try block attempts to execute the code that might raise exceptions. If an exception occurs, the appropriate except block is executed. The else block is executed if no exceptions are raised, and the finally block always executes, regardless of whether an exception occurred or not. Finally, let's discuss custom exceptions and advanced error handling strategies. Custom exceptions allow you to define your own exception types for specific scenarios, enhancing code clarity and control. Here's an example of defining and raising a custom exception. In this example, value2higherror is a custom exception class that inherits from the base exception class. We define a function test_value that raises this custom exception if the input value exceeds 100. tools. And debugging is the process of identifying and fixing errors in your code. It's an essential skill for every programmer. One of the simplest ways to debug your code is by using print statements to track variable values and program flow. However, for more complex debugging, Python's built-in PDB module can be incredibly helpful. Let's look at a quick example using PDB. Using pdb.set_trace allows you to set breakpoints and step through your code interactively. You can inspect variables, execute code line by line, and understand the program's behavior. Next, let's dive into unit testing using Python's built-in Unitest framework. Unit testing involves writing tests for individual units of code to ensure they work as expected. Here's an example of how you can write a unit test using the Unitest framework. In this example, we define a test class TestMath_operations that inherits from Unitest.testCase. Inside this class, we write test methods like test_add to check the functionality of the add function. Running Unitest.main executes all test methods in the script. Finally, let's talk about writing clean and maintainable code. Clean code is easier to read, understand, and maintain, which is crucial for long-term project success. Here are some tips for writing clean and maintainable code. Follow naming conventions, use descriptive and consistent names for variables, functions, and classes. Keep functions small, each function should perform a single task. Use comments and docstrings, explain the purpose of complex code blocks and functions. Consistent indentation and formatting, follow a consistent style guide like PEP8. By following these tips, you'll write code that's not only functional, but also clean and maintainable. This will make debugging and testing much easier. A module in Python is simply a file containing Python code that you can import and reuse in other scripts. Here's an example of creating a module. This is a simple module named my_module.py. It contains two functions, greet and add. Now, let's see how we can import and use this module in another script. As you can see, we use the import statement to bring in my_module and then call its functions using the dot notation. Next, let's talk about organizing your code into packages. A package is a way to organize related modules into a directory hierarchy. Here's how you can create a package. Create a directory named myPackage. Inside myPackage, create an empty file named init.py to indicate that this directory is a package. Add your module files inside myPackage. Now, let's see how you can use the modules in this package. By using the from keyword, we can import specific modules from the package and use them directly. Finally, let's discuss namespaces and import aliases. A namespace is a container that holds a set of identifiers and ensures that all the names in a program are unique to avoid naming conflicts. Here's an example of using namespaces. In this example, math and random are namespaces that contain functions with the same names but do different things. Sometimes, you might want to use shorter names for modules. This is where import aliases come in handy. Here, we import the NumPy module as NP, making it quicker and easier to use in our code. Regular expressions are sequences of characters that define a search pattern, primarily used for string matching. In Python, we use the re module to work with regex. Here's how you can import it. Regex can be daunting at first, but once you get the hang of it, it becomes an invaluable tool. Let's look at a basic example. In this example, D is a regex pattern that matches one or more digits in the text. reFindAll returns all matches of the pattern in the text. Next, let's talk about pattern matching and searching. Regex allows you to perform complex searches in strings. Here's how you can search for patterns in text. The reSearch function searches the string for a match to the pattern and returns a match object. The group method of the match object returns the part of the string where there was a match. You can also use rematch to check if the pattern matches at the beginning of the string. Finally, let's explore how to use regex for string manipulation. Regex can help you perform substitutions, splits, and more. Here's an example of replacing text using regex. The resub function replaces all matches of the pattern with the specified replacement string. You can also use regex to split strings. The resplit function splits the string at each match of the pattern, returning a list of substrings. List comprehensions for filtering and transforming data. List comprehensions provide a concise way to create lists. Here's a basic example of a list comprehension. In this example, the list comprehension generates a list of squares of numbers from 0 to 9. Now, let's add a condition to filter data. Here, only even numbers are squared and included in the list. This shows how you can filter data using list comprehensions. Next, let's explore nested list comprehensions. These are list comprehensions within other list comprehensions. Here's an example of a nested list comprehension. In this example, the outer list comprehension creates rows, and the inner list comprehension creates columns. This generates a multiplication table. Let's see another example with nested comprehensions for flattening a list of lists. Here, the nested comprehension flattens the list of lists into a single list. Finally, let's talk about using comprehensions effectively. While comprehensions are powerful, they should be used judiciously to maintain code readability. Here are some tips for using comprehensions effectively. 1. Keep it simple, avoid overly complex comprehensions. If it's hard to read, consider using regular loops. 2. Use with functions. You can use comprehensions with functions to make your code more expressive. 3. Combine with conditionals. Use conditionals within comprehensions to filter data. Remember, the goal is to write clean and efficient code. If a comprehension makes your code clearer and more concise, use it. If it complicates your code, opt for traditional loops. Decorators. Decorators are a powerful tool in Python that allows you to modify the behavior of functions or classes. A decorator is a function that takes another function and extends its behavior without explicitly modifying it. Here's a simple example. In this example, the @my_decorator syntax is used to apply my_decorator to say_hello. When say_hello is called, the wrapper function is executed, adding additional behavior before and after the original function call. Now, let's create our own custom decorators. This will help you understand how decorators can be tailored to fit your needs. Here's an example of a custom decorator that logs the execution time of a function. In this example, the timer_decorator calculates the execution time of the compute_square function. The args and quargs allow the wrapper to accept any arguments passed to the decorated function. Finally, let's talk about function annotations. Type annotations in Python provide a way to indicate the expected data types of function arguments and return values, making your code more readable and easier to debug. Here's how you can add type annotations to a function. In this example, name str indicates that the name parameter should be a string, and -str indicates that the function returns a string. Let's see another example with multiple parameters and different return types. Type annotations help you and others understand the expected input and output of your functions, making your code more maintainable. Generators. Generators are a simple way to create iterators using a function that yields values one at a time, instead of returning them all at once. Here's a basic example of a generator function. In this example, the simple underscore generator function yields values one at a time. Each call to next retrieves the next value from the generator. Generators can also be used to generate an infinite sequence of values. This infinite underscore sequence generator yields an endless sequence of numbers. Be careful with infinite generators, they can consume a lot of resources if not handled properly. Next, let's talk about iterators and iterables. An iterable is an object that can return an iterator, and an iterator is an object that represents a stream of data. Here's an example of using iterators and iterables. In this example, my_list is an iterable, and iter my_list returns an iterator. The next function retrieves elements from the iterator one by one. You can also create custom iterators by defining iter and next methods in a class. Here, the counter class is an iterable that counts from a low number to a high number. Finally, let's talk about lazy evaluation and memory optimization. Generators and iterators are great for handling large datasets because they generate items one at a time, only when needed. Here's an example of a generator function that reads a large file line by line. In this example, the read_large_file generator reads lines from a file one at a time. This is much more memory efficient than reading the entire file into memory at once. Generators are also useful for handling large or infinite sequences, as they only compute values as needed, which can save a lot of memory. And the with statement simplifies exception handling by encapsulating common preparation and cleanup tasks in so-called context managers. Here's a basic example of using the with statement to open a file. In this example, the with statement ensures that the file is properly closed after its sweep finishes, even if an exception is raised. This makes your code cleaner and more readable. Next, let's talk about creating custom context managers. You can create a custom context manager by defining a class with __enter___ and __exit__ methods, or by using the context_lib module. Here's an example of a custom context manager using a class. In this example, the enter method is called when the execution enters the context of the with statement, and the exit method is called when the execution leaves the context. The context manager decorator turns a generator function into a context manager, making it easier to write and understand. Finally, let's talk about managing resources effectively. Context managers are great for managing resources such as files, network connections, and locks. Here's an example of using a context manager to manage a database connection. In this example, the open_database context manager ensures that the database connection is properly committed and closed, even if an exception is raised. This helps prevent resource leaks and ensures that your resources are managed efficiently. Let's start with JSON, which stands for JavaScript Object Notation. It's a lightweight data interchange format that is easy for humans to read and write, and easy for machines to parse and generate. Here's an example of reading a JSON file. In this example, we use the JSON.load function to read data from a JSON file and print it. Now, let's write some data to a JSON file. In this example, we use the JSON.dump function to write data to a JSON file with an indentation of 4 spaces for readability. Next, let's talk about parsing JSON data. Parsing is the process of converting a JSON string into a Python dictionary. Here's an example of parsing JSON data from a string. In this example, we use the JSON.loads function to parse a JSON string into a Python dictionary. You can also convert a Python dictionary back into a JSON string. Here, we use the JSON.dumps function to convert a Python dictionary into a JSON string with an indentation of 4 spaces for readability. Finally, let's talk about handling CSV files. CSV stands for comma-separated values, and it's a simple format for storing tabular data, such as a spreadsheet or database. Here's an example of reading a CSV file. In this example, we use the CSV.reader function to read data from a CSV file and print each row. Now, let's write some data to a CSV file. In this example, we use the CSV.writer function to write data to a CSV file, row by row. For more advanced CSV handling, you can use the dictReader and dictWriter classes, which work with dictionaries instead of lists. In this example, dictReader reads each row as a dictionary, and dictWriter writes dictionaries to a CSV file with specified field names. And ready to explore the web in a whole new way? Let's get started. Web scraping is the process of extracting data from websites. It allows you to collect large amounts of data from the web, which you can then analyze and use for various purposes. For example, you might want to scrape product information from an e-commerce site, collect news articles from different sources, or gather weather data from multiple locations. However, it's important to respect the website's terms of service and robots.txt file to ensure you're not violating any rules or causing harm to the server. To start web scraping, you first need to fetch the web content. We can do this using the requests library, which is a simple and easy-to-use HTTP library for Python. Here's how you can fetch a web page using the requests library. In this example, we use requests.get to fetch the content of the web page at the specified URL and print the HTML content. You can also check the status code to ensure the request was successful. A status code of 200 indicates that the request was successful, while other codes can indicate various types of errors. After fetching the web content, the next step is to parse the HTML. For this, we'll use Beautiful Soup, a powerful library for parsing HTML and XML documents. Here's how you can parse HTML using Beautiful Soup. In this example, we create a Beautiful Soup object from the HTML content and use the prettify method to print the nicely formatted HTML. Now, let's extract specific elements from the HTML. For instance, let's say we want to extract all the hyperlinks from the page. In this example, we use the find_all method to find all tags, which represent hyperlinks, and print their ref attributes. You can also extract other elements like headings, paragraphs, or images using similar methods. These methods allow you to target specific elements and extract the data you need from the web page. Ready to unlock the power of APIs? Let's get started. So, what exactly is an API? API stands for Application Programming Interface. It's a set of rules and definitions that allow different software applications to communicate with each other. APIs are incredibly important because they enable integration between different services. For example, weather apps use APIs to get weather data, social media apps use APIs to interact with other platforms, and e-commerce sites use APIs for payment processing. In short, APIs are like bridges that connect different systems, making it easier to share and retrieve data. To interact with an API, we need to make HTTP requests. We can do this using the requests library, which we've already used for web scraping. Here's how you can make a simple HTTP GET request to an API. In this example, we use requests.get to fetch data from the API and response.json to parse the response as JSON. You can also add headers and parameters to your requests. In this example, we include headers for authorization and content type, and parameters to specify the data we want to retrieve. After making a request and receiving a response, the next step is to process the response and extract the data you need. Here's how you can extract specific data from an API response. In this example, we extract the name, age, and city fields from the JSON response and print them. You can also handle errors and check the status of your requests. A status code of 200 indicates that the request was successful. If the request fails, you can handle the error appropriately. And there you have it, folks, an introduction to APIs with Python. You've learned the basics of APIs, how to make HTTP requests, and how to process and extract data from API responses. Ready to bring your data to life? Let's get started. Matplotlib is a powerful library for creating static, animated, and interactive visualizations in Python. Let's start with some basic plots and charts. First, you need to install Matplotlib if you haven't already. You can do this using pip. Once installed, let's create a simple line plot. This code creates a basic line plot with labeled axes and a title. The plt.show function displays the plot. You can also create bar charts, histograms, scatter plots, and more. Here are a few examples. Now, let's customize the appearance of our plots to make them more informative and visually appealing. You can customize colors, line styles, markers, and more. Here's how you can do it. In this example, we customize the line color, style, and markers. We also add a grid to the plot for better readability. You can also add legends, change figure sizes, and adjust font properties. In this example, we add a legend to differentiate between the two data series. Data visualization is not just about making pretty charts, it's about uncovering trends and insights. Let's explore some techniques to visualize data trends. You can use Matplotlib to create trend lines, highlight important data points, and visualize statistical information. In this example, we plot a sine wave and a data point with a slight noise to visualize the trend. You can also use subplots to compare multiple charts side by side. Subplots are great for comparing different datasets and visualizing complex data relationships. Ready to unlock the power of Pandas? Let's get started. Pandas is a powerful and flexible data analysis and manipulation library for Python. It's built on top of NumPy and provides data structures and functions needed to work on structured data seamlessly. First, let's install Pandas if you haven't already. You can do this using pip. Once installed, let's import Pandas and get started. One of the first steps in data manipulation is loading your dataset into a Pandas data frame. Let's see how to do that. You can load data from various file formats such as CSV, Excel, SQL databases, and more. Here's how you load a CSV file. The read_CSV function reads the CSV file and stores it in a data frame. The head method displays the first 5 rows of the data frame, giving us a quick look at the data. You can also load data from Excel files. Pandas also provides methods to explore your dataset. You can use info to get a concise summary and describe to get descriptive statistics. Data indexing and selection are crucial for manipulating and analyzing data effectively. Let's explore how to select specific rows and columns in a data frame. You can select columns by their names. To select rows, you can use the iloc and LOC methods. iloc is used for integer-based indexing, while LOC is for label-based indexing. You can also filter data based on conditions. And there you have it, folks, an introduction to data manipulation with pandas. You've learned how to load and explore datasets, and how to index is crucial when working with datasets. Let's start by filtering data based on conditions. You can filter rows in a data frame based on conditions. For example, let's filter rows where age is greater than 30. You can also transform data using methods like apply and map. For example, let's convert all names to uppercase. Grouping and aggregation are powerful techniques for summarizing data. Let's see how to group data and perform aggregation functions. You can group data by a column and then apply aggregation functions like sum, mean, etc. For example, let's group by city and calculate the average age. You can also use multiple aggregation functions. Handling missing data is essential for maintaining data quality. Let's explore some methods to handle missing data in pandas. You can check for missing data using the isNull method and sum them up to get the total count of missing values. To handle missing data, you can either drop the rows or columns with missing values or fill them with a specific value. And there you have it, folks, an in-depth look at data manipulation with pandas. You've learned how to filter and transform data, perform grouping and aggregation, and handle missing data effectively. And joining datasets is essential when working with multiple data sources. Let's start by merging two data frames. You can merge data frames using the merge function. For example, let's merge two data frames on a common column, ID. You can also perform different types of joins like left, right, and outer joins. For example, let's do a left join. Time series data is common in many fields, and pandas provides excellent support for it. Let's explore how to work with time series data. You can create a date-time index and perform operations on time series data. For example, let's create a data frame with date-time index. You can also resample the data to different frequencies. For example, let's resample the data to a weekly frequency. Exporting data is crucial for sharing and storing your work. Let's see how to export data frames to different formats. You can export data frames to CSV, Excel, and JSON formats using pandas. For example, let's export a data frame to a CSV file. And that's how you can easily export your data to various formats using pandas. NumPy arrays are the foundation of numerical computing in Python. They are more efficient and powerful than Python lists. Let's start by creating a simple NumPy array. First, you need to import the NumPy library. You can install it using pip install numpy if you haven't already. Then, create an array. As you can see, we've created a one-dimensional array. NumPy arrays can also be multidimensional. Here's an example of a two-dimensional array. NumPy provides a wide range of operations to manipulate arrays. Let's see some basic operations. You can perform element-wise operations on NumPy arrays. For example, let's add two arrays. You can also perform operations like multiplication, division, and more. NumPy also provides powerful functions for array manipulation, such as reshaping arrays. NumPy includes a wide range of mathematical and statistical functions. Let's explore some of them. You can use NumPy to perform basic statistical operations, such as finding the mean, median, and standard deviation. You can also perform more complex mathematical operations, such as finding the sine or cosine of array elements. SQL, or Structured Query Language, is the standard language for managing and manipulating relational databases. Relational databases store data in tables, which are made up of rows and columns. Let's dive into the basics of SQL. Here's a simple relational database schema. It consists of tables, each with columns that define the data types and rows that store the actual data. Common SQL commands include select for querying data, insert for adding new data, update for modifying existing data, delete for removing data. SQLite is a lightweight, disk-based database that doesn't require a separate server process. It's perfect for small to medium-sized applications. Let's see how to use SQLite with Python. First, you need to import the SQLite 3 module, which comes included with Python. Let's create a database and a table. We've just created a database named example.db and a table called users with columns for ID, name, and age. Now, let's write and execute some SQL queries to interact with our database. We'll start by inserting some data and then querying it. Let's insert some records into the users table. Now that we have some data, let's query it. You can also update and delete records using SQL. And that's how you can manage and manipulate data using SQL and SQLite in Python. SQL is a powerful language, and today we'll explore some advanced features like joins, subqueries, and complex queries. Let's start with joins. Joins are used to combine rows from two or more tables based on a related column. Here are the different types of joins. Inner join returns only the matching rows from both tables. Left join returns all rows from the left table and the matched rows from the right table. Right join returns all rows from the right table and the matched rows from the left table. Full outer join returns all rows when there is a match in either left or right table. Let's see an example using inner join. Suppose we have two tables, users and orders. We want to find all orders placed by users. Subqueries are queries within queries. They help us perform complex filtering and data extraction. Here's an example of a subquery to find users who have placed orders. You can also write complex queries combining multiple SQL features. Let's move on to indexing and optimization techniques. Indexing is crucial for improving the performance of database queries. An index on a column allows the database to find rows much faster. To create an index, you can use the create index statement. Here's how to create an index on the name column of the user's table. Now, let's talk about query optimization. Some techniques include using indexes. As we've seen, indexes speed up data retrieval, avoiding unnecessary columns. Select only the columns you need. Proper use of joins. Ensure you're using the most efficient join for your query. Using explain. This command helps you understand how your query is being executed. Here's how to use explain to analyze a query. Python allows us to work with various database systems like MySQL, PostgreSQL, and SQLite. Let's see how to connect to different databases using Python. Here's an example of connecting to a MySQL database using the MySQL Connector Python library. Similarly, you can connect to PostgreSQL using the scicop2 library. Whether you're using MySQL, PostgreSQL, or SQLite, Python makes it easy to interact with multiple database systems. Flask is a lightweight web framework for Python that makes it easy to build web applications. Let's start by setting up a basic Flask application. First, make sure you have Flask installed. You can install it using pip. Once Flask is installed, create a new file called a pp.py. Open a pp.py in your text editor and add the following code. This code sets up a basic Flask application. The @app_root / decorator defines the home root, which returns the string a hello, Flask, when accessed. The app run debug = true command runs the application in debug mode, which is useful for development. Now, open your web browser and go to http://127.0.0.1:5000. You should see a hello, Flask, displayed on the page. Next, let's create more routes and handle different types of requests. Routes in Flask are defined using the @app_root decorator. Let's add a new route that handles a GET request. Update your app.py file with the following code. Restart your Flask application and go to http://127.0.0.1:5000 about. You should see this is the About page. Flask also allows you to handle different types of requests, such as POST. Let's create a form and handle form submissions. This code creates a route that handles both GET and POST requests. If the request method is POST, it retrieves the name from the form and returns a greeting. If it's a GET request, it displays the form. Flask uses Jinja2 as its templating engine, which allows us to create dynamic HTML pages. Let's create a template and render it. First, create a folder called Templates in your project directory. Inside the Templates folder, create a new file called index.html and add the following code. Now, update your app.py file to render this template. This code uses the render_template function to render the index.html template and passes a message variable to it. When you refresh the page, you'll see the message Hello, Flask with Jinja2 displayed in the template. Handling forms and validating user input are essential parts of web development. Let's start by creating a form and handling its submission. First, make sure you have Flask installed. You can install it using pip. Once Flask is installed, create a new file called a pp.py. Open a pp.py in your text editor and add the following code. This code sets up a basic Flask application with a form handling route. If the form is submitted with an empty name, it displays an error message. Otherwise, it greets the user by name. Now, run your Flask application and open your web browser to http://127.0.0.1:5000. You should see the form, and when you submit it, it either greets you or shows an error if the input is empty. Next, let's use templates to render dynamic content. Flask uses Jinja 2 for templating, allowing us to create reusable and dynamic HTML files. We already have an index.html template. Let's create another route that displays a list of items dynamically. Now, create a new template file called items.html in the templates folder. This template renders a list of items passed from the Flask application. When you navigate to http://127.0.0.1:5000 items, you'll see the list displayed dynamically. Finally, let's implement CRUD operations: create, read, update, and delete. These operations are the backbone of most web applications. We'll use a simple list to store our data for this example. Here's how to implement basic CRUD operations. Here's how it works. The home route displays the list of items. The add route handles form submissions to add new items. The delete route removes an item by its index. Now, you can add items to the list and delete them using the provided links. When you navigate to http://127.0.0.1:5000, you'll see the form and the dynamic list of items with delete links. Databases are crucial for most web applications. Today, we'll learn how to integrate a database with Flask using SQL Alchemy, a powerful ORM for SQL databases. First, ensure you have Flask SQL Alchemy installed. You can install it using pip. Next, create a new file called app.py. Open app.py in your text editor and add the following code. This code sets up a basic Flask application with an SQLite database using SQL Alchemy. We define a user model with ID, username, and email fields. To create the database, open a Python shell and run the following commands. Now, let's add user authentication and authorization to our Flask app. We'll use Flask Login for this purpose. First, install Flask Login. Next, update app.py to include user login functionality. This code adds login, logout, and account routes to our Flask app. It uses Flask Login to manage user sessions and Flask SQL Alchemy to handle database interactions. Create a new template file called login.html in the templates folder. Now, run your Flask application, navigate to http://127.0.0.1:5000 login, and you should see the login form. You can now test logging in and accessing the account page. Finally, let's deploy our Flask app to a hosting provider. We'll use Heroku for this example. First, make sure you have the Heroku CLI installed. You can download it from the Heroku website. Then, log into your Heroku account. Next, create a procfile in the root directory of your project with the following content. This tells Heroku to use Gunicorn to run our Flask app. Install Gunicorn if you haven't already. Create a requirements.txt file to list all the dependencies. Now, create a new Heroku app and push your code to Heroku. After the deployment is complete, open your app in the browser. And Django is a high-level Python web framework that encourages rapid development and clean, pragmatic design. It's built by experienced developers to help you save time and effort in building web applications. let's break down its main components. 1. Models represent the database schema and data structure. 2. Templates control how data is presented to the user. 3. Views contain the logic that handles user requests and returns responses. Dango comes with several built-in features like an ORM for database interactions, a templating engine, and an admin panel for managing site content. Let's create our first Dango project and app. First, ensure you have Dango installed. You can install it using pip. Next, create a new Dango project by running dango admin start project my site. This command creates a new directory called my site with the following structure. Navigate into the project directory and create a new app. This command creates a new directory called blog with the following structure. Now, let's add our new app to the project settings. Open my site settings.py and add a blog to the installed_apps list. Dango follows the MTV, model template view, architecture, which separates the data access logic, business logic, and presentation logic. Let's understand each component with a simple example. First, let's define a model in blog or models.py. This model defines a post with title, content, and date_posted fields. To create the database table for this model, run Python manage.py make migrations, Python manage.py migrate. Next, let's create a view in blog or views.py that retrieves all posts and renders them using a template. Now, create the template blog to templates blogger home.html. Finally, map the view to a URL. Update my site to urls.py. Start the development server by running python manage.py run server. Open your browser and navigate to http://127.0.0.1:8000 to see the blog posts rendered on the home page. Right into defining models and creating a database schema. Models in Dango define the structure of your database, essentially your data schema. Let's create a post model for our blog application. Open blog.models.py and define the post model. This model defines a post with a title, content, and date_posted fields. Next, let's create the database schema by running Python manage.py make migrations, Python manage.py migrate. The make migrations command creates migration files that represent the changes you made to your models, and migrate applies those changes to the database. One of Dango's coolest features is the built-in admin interface, which allows you to manage your application's data easily. To use it, you need to register your models with the admin site. Open Blogs Administration PY and register the post model. Create a super user to access the admin interface. After creating the super user, start the development server. Navigate to http://127.0.0.1:8000 admin in your browser and log in with your superuser credentials. You should see the admin interface, where you can add, edit, and delete post objects. Now, let's use Dango templates to render dynamic content. Templates in Dango help you separate the presentation logic from the Python code. Let's create a simple view to display all blog posts on the homepage. Open blog.views.py and define a view that retrieves all posts and renders them using a template. Now, create a template directory inside the blog app. Within this directory, create a new folder named blog, and inside it, create a file named home.html. In home.html, add the following HTML to display the posts. Finally, update visitor-urls.py to map the home view to the root URL. Start the development server again if it's not running. Open your browser and navigate to http://127.0.0.1:8000 to see the blog posts displayed on the home page. Let's start with creating views and handling URL routing. Views in Django are responsible for processing user requests and returning responses. We've already created a simple view for our blog homepage. Today, we'll add more views to handle different functionalities. Open blog-views.py and add the following views. Next, update visitor-urls.py to include the new view. This sets up URL routing to handle requests for individual blog posts using the primary key, PK, to identify them. Now let's move on to form handling and validation. Django makes it easy to handle forms and validate user input. We'll create a form to allow users to create new blog posts. First, create a forms file. In blog, create a new file named forms.py and define a form for our post model. Next, create a view to handle the form. Update blog-views.py. Now, add the URL pattern for the new view in my site urls.py. Finally, create the template blog to templates blog create_post.html. This form allows users to create new blog posts. The CSRF_ token ensures that the form submission is secure. Last but not least, let's implement user authentication and permissions. Django provides a built-in user authentication system that handles user login, logout, and registration. First, add authentication views provided by Django to visitor-urls.py. Next, create templates for login and logout views in users' templates users login.html. Logout.html. To restrict access to the post creation view, update blog-views.py. Now, users need to log in to create a new post. Start the development server again if it's not running. Open your browser and navigate to http://127.0.0.1:8000 login to see the login page. Let's start by understanding the principles of REST, which stands for Representational State Transfer. REST is an architectural style for designing networked applications. It relies on stateless, client-server communication and uses standard HTTP methods like GET, POST, PUT, and DELETE. In REST, resources are identified by URLs, and you interact with these resources using HTTP methods. For example, GET, retrieve data from the server, POST, send data to the server, PUT, update data on the server, DELETE, remove data from the server. Now that we understand the basics, let's create a simple RESTful API. We'll use Flask, a lightweight web framework for Python, to create our RESTful API. First, ensure you have Flask installed. Let's create a basic Flask app. Create a new file called app.py and add the following code. This code sets up routes for handling CRUD operations on posts. Start the Flask app by running. Now, your API is running locally on http://127.0.0.1:5000. You can use tools like Postman or curl to interact with the API. Let's make some API requests and handle the responses. We'll use Python's requests library to do this. First, ensure you have the requests library installed. Create a new file called client.py and add the following code to make API requests. Run client.py to see the API requests in action. You'll see the responses for each API request, demonstrating how to interact with a RESTful API using Python. The requests library in Python is a powerful tool for making HTTP requests. Whether you need to get data, post data, or handle other HTTP methods, requests has got you covered. First, ensure you have the requests library installed. Let's start with a simple GET request. Create a new file called API_client.py and add the following code. This code makes a GET request to the GitHub API and prints the status code and response in JSON format. Run the script. You should see a status code of 200 and a JSON response containing information about the GitHub API. Many APIs require authentication. Let's look at how to send authenticated requests and use different HTTP methods like POST, PUT, and DELETE. For this example, we'll use the JSON Placeholder API, which is a free online REST API for testing and prototyping. Let's create a POST request to add a new resource. This code sends a POST request to the JSON Placeholder API to create a new post. Run the script. You should see a status code of 201 and a JSON response with the new post data. Similarly, we can use PUT to update a resource and DELETE to remove a resource. Here's how. The PUT request updates the post with ID 1, and the DELETE request removes it. Run the script to see the outputs. Now let's focus on handling API responses and manipulating the data we receive. Often, you'll need to parse JSON and work with the data in Python. Let's fetch some posts and extract specific information from the response. This code retrieves all posts and extracts their titles using a list comprehension. Run the script. You should see a list of titles from the posts. This is a common way to manipulate data received from an API. Additionally, you might encounter errors when making API requests. Let's handle these gracefully. This code checks the status code of the response and prints an error message if the request fails. Run the script to see how it handles a non-existent post. And data science is a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from data. It's used in various industries like finance, healthcare, marketing, and more to make data-driven decisions. For example, in finance, data science is used for algorithmic trading, fraud detection, and risk management. In healthcare, it's used for predictive analytics, personalized medicine, and medical imaging. In marketing, it's used for customer segmentation, sentiment analysis, and targeted advertising. To get started with data science in Python, you'll need to install some essential libraries, NumPy, Pandas, and Matplotlib. These libraries provide powerful tools for numerical computing, data manipulation, and data visualization. First, let's install these libraries. Open your terminal and run the following command. Great! Now let's dive into each of these libraries. NumPy is a fundamental library for numerical computing in Python. It provides support for arrays, matrices, and many mathematical functions. Let's create a simple NumPy array. This code creates a 1D and a 2D array using NumPy. Let's run the script to see the output. You should see the 1D and 2D arrays printed in the terminal. Pandas is an essential library for data manipulation and analysis. It provides data structures like series and data frame to handle and analyze data efficiently. Let's create a simple data frame using Pandas. This code creates a data frame with 3 columns: name, age, and city. Let's run the script to see the output. You should see the data frame printed in the terminal with the provided data. Matplotlib is a powerful library for data visualization. It allows you to create a wide variety of static, animated, and interactive plots. Let's create a simple line plot using Matplotlib. This code creates a simple line plot with X and Y data points. Let's run the script to see the output. You should see a line plot with markers at each data point. In any dataset, dealing with missing data is crucial for maintaining data integrity. Let's explore how to handle missing data using the Pandas library. First, let's create a data frame with some missing values. This code creates a data frame with missing values. Let's run the script to see the output. Now, let's handle these missing values. We can fill them with a specific value, like the mean, or drop them entirely. Let's run the script to see the output after handling missing values. Next, let's tackle duplicates and outliers. Removing duplicates helps ensure data accuracy, and handling outliers is important for reliable analysis. Here's how to remove duplicates from a data frame. Let's run the script to see the output after removing duplicates. Now, let's handle outliers. We'll use the interquartile range (IQR) method to identify and remove outliers. Let's run the script to see the output after removing outliers. Finally, let's normalize and scale the data to bring all features to a similar scale, which is essential for many machine learning algorithms. Here's how to normalize and scale data using the Minitemax scaler from scikit-learn. Let's run the script to see the output after normalizing the data. Descriptive statistics help us understand the basic characteristics of our data. Let's use Pandas to get some insights into a dataset. Here's how to summarize data with descriptive statistics. Let's run the script to see the output. Visualizations help us understand data better. Let's create some plots to visualize our dataset. Here's how to create a bar chart and a scatter plot using Matplotlib. Let's run the script to see the output plots. Finally, let's identify patterns and insights in our data. We'll use correlation to see the relationship between age and salary. Here's how to calculate and visualize the correlation between age and salary. Let's run the script to see the output. So, what exactly is machine learning? Simply put, machine learning is a field of artificial intelligence that enables computers to learn from and make decisions based on data. Instead of being explicitly programmed to perform a task, a machine learning model is trained on data to recognize patterns and make predictions. Machine learning can be broadly categorized into 3 types. 1. Supervised learning. The model is trained on labeled data, meaning the input comes with the correct output. The model learns to map the input to the output. Examples include classification and regression. 2. Unsupervised learning. The model is trained on unlabeled data and tries to find patterns or structures in the data. Examples include clustering and association. 3. Reinforcement learning: the model learns by interacting with an environment and receiving feedback through rewards or penalties. This type is often used in gaming and robotics. Alright, now it's time to get hands-on. We'll be using scikit-learn, a powerful and user-friendly Python library for machine learning. Let's build a simple model to predict housing prices based on features like the number of rooms and the size of the house. First, let's import the necessary libraries. Next, we'll create a small dataset. Now, we'll split the data into training and testing sets. Let's train our model using linear regression. And now, we'll make predictions and evaluate our model. Here's the output of our simple machine learning model. As you can see from the scatter plot, the predicted prices are quite close to the actual prices, indicating that our model has learned to some extent from the training data. Linear regression is one of the simplest and most widely used algorithms in machine learning. It models the relationship between a dependent variable and one or more independent variables using a straight line. Here's the equation of a simple linear regression model. Y equals mx plus b, where y is the dependent variable, x is the independent variable, m is the slope of the line, b is the y-intercept. Let's see how we can implement linear regression in Python using scikit-learn. Let's train a linear regression model using a sample dataset and evaluate its performance. Here's the code to train and evaluate a regression model. Let's run the script to see the output. Overfitting and underfitting are common issues in machine learning. Let's understand what they are and how to deal with them. Overfitting occurs when the model learns the training data too well, capturing noise and fluctuations. This results in poor generalization to new data. Underfitting occurs when the model is too simple to capture the underlying pattern in the data, resulting in poor performance on both training and test data. Here are some techniques to deal with overfitting and underfitting. Dealing with overfitting: use simpler models, regularization techniques, e.g., lasso, ridge, cross-validation. Dealing with underfitting: use more complex models, add more features, reduce regularization. Let's add regularization to our linear regression model to prevent overfitting. Here's the code to use ridge regression for regularization. Let's run the script to see the output. Classification is all about predicting categorical outcomes. For instance, whether an email is spam or not, or whether a tumor is malignant or benign. Essentially, classification models assign labels to new data points based on their features. Here's a quick example. Features: email text, labels, spam, not spam. Let's jump into Python and implement a basic classification example. There are several algorithms we can use for classification. Today, we'll look at logistic regression, decision trees, and k-nearest neighbors. Here's how you can implement these algorithms using scikit-learn. Let's run the script to see the output. Decision tree example. K-nearest neighbors example. Evaluating classification models involves looking at various metrics. Here are the most common ones: accuracy, the ratio of correctly predicted instances to the total instances; precision, the ratio of correctly predicted positive observations to the total predicted positives; recall, the ratio of correctly predicted positive observations to all observations in the actual class; F1 a score, the weighted average of precision and recall. These metrics can be calculated using scikit-learn as we saw in the examples above. While our models performed perfectly on this simple dataset, in real-world scenarios, we often need to balance these metrics to choose the best model for the task. Clustering is a type of unsupervised learning where the goal is to group similar data points together. Unlike supervised learning, clustering doesn't require labeled data. It's widely used in customer segmentation, image compression, and more. Here's a simple example of how clustering can group similar data points. Let's jump into Python and implement some clustering algorithms. Two popular clustering algorithms are k-means clustering and hierarchical clustering. K-means is great for partitioning data into k clusters, while hierarchical clustering builds a tree of clusters. Here's how you can implement these algorithms using scikit-learn. Let's run the script to see the output. Hierarchical clustering example. Let's run the script to see the output. Evaluating clustering results can be tricky since we don't have true labels. However, metrics like the silhouette score and inertia for k-means can help us understand the quality of our clusters. Let's see how to calculate these metrics. Dimensionality reduction is a technique used to reduce the number of features in a dataset while retaining as much information as possible. This is crucial for visualizing high-dimensional data and improving the performance of machine learning models. Here's a simple example of a high-dimensional dataset that will reduce to 2D for easier visualization. Principal component analysis, or PCA, is one of the most popular techniques for dimensionality reduction. It transforms the data into a new coordinate system where the greatest variance comes to lie on the first principal component, the second greatest variance on the second component, and so on. Let's implement PCA using Python. Let's run the script to see the output. TSNE, or T-distributed stochastic neighbor embedding, is another powerful technique for visualizing high-dimensional data. It's particularly good at preserving the local structure of the data. Here's how you can use TSNE to visualize high-dimensional data. Let's run the script to see the output. Dive into NLP techniques, let's understand the basics of working with text data. Text data is unstructured and requires special pre-processing steps to be used in machine learning models. Let's start by loading some sample text data using Python. Now that we have our text data, let's move on to tokenization and stemming. Tokenization is the process of breaking down text into individual words or tokens. Stemming reduces words to their base or root form. These steps are crucial in preparing text data for analysis. Let's implement tokenization and stemming using the Natural Language Toolkit, NLTK. Tokenization and stemming are done. Now, let's use this pre-processed text data to create a simple text classification model. Now, we'll create a simple text classification model using the pre-processed text data. We'll use the count vectorizer to convert text to a numerical format and multinomial NB for our classification model. Here's how we can build and train our model. And there you have it! We've successfully built a simple text classification model with 100% accuracy on our small dataset. Remember, this is just a starting point, and there's so much more to explore in NLP. NLP involves various tasks and techniques, and libraries like NLTK and spaCy make these tasks much easier. NLTK is great for teaching and research, while spaCy is designed for production use and is known for its speed. Let's start by installing and importing these libraries. With the libraries installed and models loaded, we're ready to explore Named Entity Recognition, or NER. Named Entity Recognition, or NER, identifies proper names of people, organizations, locations, and other entities in text. This helps in extracting valuable information from large text corpora. Let's see how NLTK and spaCy handle NER. Example code, spaCy. As you can see, spaCy provides a more straightforward and production-ready approach to NER. Sentiment analysis determines the sentiment or emotion behind a piece of text, like positive, negative, or neutral. It's widely used in analyzing reviews, social media, and customer feedback. Let's perform sentiment analysis using NLTK's VADA Sentiment Analyzer. That's how we can quickly analyze the sentiment of text using NLTK. You can see how it breaks down the sentiment into negative, neutral, positive, and compound scores. What exactly is deep learning? In simple terms, deep learning is a subset of machine learning that uses neural networks with many layers, hence the term deep, to model and solve complex problems. Traditional machine learning models rely on manual feature extraction and selection. Deep learning, on the other hand, automatically discovers representations from data, making it incredibly powerful for tasks like image recognition, natural language processing, and more. At the heart of deep learning are neural networks. These are inspired by the human brain and consist of layers of interconnected nodes or neurons. Let's break down the main components. Input layer. This is where the data enters the network. Hidden layers. These layers perform computations and extract features from the data. Output layer. This layer produces the final prediction or output. Each connection between neurons has a weight, which is adjusted during training to minimize the error in predictions. Now, let's get hands-on and build a simple neural network using Keras, a high-level deep learning library in Python. We'll create a neural network to classify handwritten digits from the famous MNIST dataset. First, let's install and import the necessary libraries. TensorFlow is a powerful open-source library developed by Google for numerical computation and large-scale machine learning. It's designed to be flexible and comprehensive, supporting a range of tasks from building machine learning models to deploying them in production. The TensorFlow ecosystem includes tools like TensorBoard for visualization, TensorFlow Extended, TFX, for end-to-end machine learning pipelines, and TensorFlow Lite for mobile and embedded devices. Now, let's get hands-on and build a more complex neural network using TensorFlow and Keras. We'll work with the Sapphire 10 dataset, which consists of 60,032 by 32 color images in 10 classes, with 6,000 images per class. First, let's install and import the necessary libraries. With just a few lines of code, we've built a convolutional neural network, CNN, that can classify images from the CIFAR-10 dataset. Notice how we used convolutional and pooling layers to capture spatial hierarchies in the data. Once our model is trained, it's crucial to evaluate its performance and fine-tune it for better results. Let's see how we can do that. We can use the evaluate method to check our model's accuracy on the test set. Our model achieved an accuracy of about 69% on the test set. To improve this, we can fine-tune hyperparameters, add more layers, or use techniques like data augmentation and dropout. By using data augmentation, we can improve our model's robustness and potentially achieve better performance. CNNs are a type of deep learning model specifically designed for processing structured grid data, like images. They leverage the spatial structure of images through convolutional layers, pooling layers, and fully connected layers. Convolutional layers apply filters to the input image, detecting features like edges, textures, and patterns. Pooling layers downsample the spatial dimensions, reducing the number of parameters and computations. Finally, fully connected layers output the final classification. Let's build a simple CNN for image classification using the MNIST dataset, which consists of handwritten digits. We'll use TensorFlow and Keras for this task. First, let's install and import the necessary libraries. With just a few lines of code, we've built a CNN that can classify handwritten digits with high accuracy. This model uses 2 convolutional layers, 2 pooling layers, and 2 dense layers with a dropout layer to prevent overfitting. Transfer learning allows us to leverage pre-trained models on large datasets, saving time and improving performance. We'll use a pre-trained model like VGG16 for image classification on a new dataset. Let's import the VGG16 model and fine-tune it for our task. By leveraging the VGG16 model, we can achieve high accuracy with significantly less training data and time. This is the power of transfer learning. So, what makes RNN special? Unlike traditional neural networks, RNNs are designed to work with sequential data that has a temporal or ordered structure. This could be anything from sentences in a text to stock prices over time, or even musical notes in a melody. RNNs are unique because they have loops in their architecture, allowing them to retain information from previous steps, which is crucial for understanding the context in sequences. Now that we understand the basics, let's build a simple RNN to handle sequential data. We'll use TensorFlow and Keras to build an RNN that can predict the next value in a sequence. Let's start by installing the necessary libraries and importing them into our project. In just a few lines of code, we've built and trained a simple RNN to predict the next value in a sine wave sequence. This model uses a simple RNN layer followed by a dense layer to output the prediction. Now, let's take a look at some real-world applications of RNNs, like text generation and sequence prediction. For text generation, we can train an RNN on a dataset of text and have it generate new sentences that mimic the style of the original text. After training, we can use the model to generate new text based on the input sequence. It's fascinating how RNNs can capture the style and structure of the input data. Things first, after training your machine learning model, you need to save it so that it can be reused without retraining. In Python, with libraries like TensorFlow or scikit-learn, saving a model is super easy. Let's start by saving a trained model using TensorFlow's Keras API. With this simple command, we've saved our trained model as a file named my_model.h5. This file can be loaded back anytime without needing to retrain the model. And that's how easy it is to save and reload your model. But what if you want to use this model in a real-world application? Let's create a web API to serve our model predictions. To deploy our model and make it accessible via the web, we can use a lightweight framework like Flask. This allows us to create a simple API where users can send data and receive predictions. Here's how to set up a basic Flask API to serve our model. With just a few lines of code, we've created an API endpoint predict where users can send their input data as JSON, and the model will return predictions. You can test this API locally or deploy it to the web for others to use. This API could be the backbone of a web app, a mobile app, or even a service that powers multiple applications. Next, let's look at how to deploy this API on a cloud platform so it's accessible from anywhere. Hosting your model on the cloud makes it accessible to users around the world, 24/7. There are many cloud platforms you can use, such as AWS, Google Cloud, and Heroku. Today, I'll show you how to deploy our Flask app on Heroku, which is free and easy to use. To deploy on Heroku, first, you need to create a requirements.txt file and a proc file for your Flask app. After setting up these files, commit your code to a Git repository and deploy to Heroku using these simple commands. And that's it! Your model is now live on the internet. Users can send requests to your API, and Heroku will handle the rest, scaling your app as needed. Seaborn is a powerful library built on top of Matplotlib that makes it super easy to create attractive and informative statistical graphics. Let's start by exploring some advanced plotting techniques with Seaborn. We'll be using the famous tips dataset, which contains information about tips received by waiters in a restaurant. Let's load the dataset and create some insightful visualizations. Here, we've created a box plot to compare the distribution of total bills by day, separated by gender. This plot helps us quickly identify the central tendency and variability of the bills, as well as any outliers. Now, let's take things up a notch with Plotly. Plotly allows us to create interactive plots that users can engage with, making your data exploration more dynamic and intuitive. Let's use Plotly to create an interactive scatter plot, showing the relationship between total bill and tip amount. This interactive scatter plot allows you to hover over points to see detailed information, and even zoom in and out to explore different aspects of the data. It's a powerful way to engage with your audience and let them explore the data on their own. Both Seaborn and Plotly excel at visualizing complex data patterns. Whether it's heat maps, pair plots, or intricate multidimensional plots, these libraries can handle it all. Let's create a pair plot in Seaborn to visualize relationships between all numeric variables in the tips dataset. This pair plot provides an overview of how different variables in the dataset relate to each other, with color coding based on gender. It's a great tool for spotting trends, correlations, and potential areas for deeper analysis. Web scraping is all about extracting data from websites. While libraries like Requests and Beautiful Soup are great for basic scraping, sometimes you need to tackle more complex sites that involve JavaScript or require interaction. That's where advanced techniques come into play. Let's say we need to scrape data from a website that dynamically loads content via JavaScript. We can use requests_HTML or even directly inject JavaScript to get the data we need. Here, we're using requests_HTML to load and render the JavaScript content of a web page, allowing us to scrape the dynamically loaded data. This is particularly useful when dealing with modern web applications that rely heavily on client-side scripting. Now, let's step it up a notch with Selenium, a powerful tool for automating web browsers. Selenium allows you to control a browser programmatically, making it perfect for tasks like logging into websites, clicking buttons, and filling out forms. Let's use Selenium to automate a simple task, like logging into a website and scraping some data from a logged-in page. This code snippet logs into a website by filling out the login form and then scrapes some data from the page you land on. Selenium is a game changer when it comes to automating tasks that require user interaction on the web. Let's put it all together and build a real-world web scraper that can extract product information from an e-commerce site. This will involve navigating through pages, clicking on products, and gathering details like price, reviews, and more. We'll use both requests_html and Selenium to handle this task. First, let's set up the scraper to collect product names and prices. Here, we've built a basic web scraper that automatically navigates through an e-commerce website and extracts the names and prices of products. This can be easily extended to scrape more data, handle pagination, or even interact with the website in other ways. So, what exactly is Tkinter? Tkinter is Python's standard GUI library, and it provides all the tools you need to create windows, buttons, labels, and more. It's super easy to get started with and perfect for building simple applications. Let's create our first Tkinter window. This will be the foundation of our GUI. This simple script creates a basic window with a title and specified dimensions. The root.main loop keeps the window open and responsive until you close it. Now that we have a window, let's add some widgets. Widgets are the elements like buttons, labels, and entry fields that make your GUI interactive. Tkinter makes it easy to place and organize these widgets with different layout managers. Let's add a label, a button, and an entry field to our window. We'll use the pack layout manager to arrange them vertically. Here, we've added a label, an entry field, and a button. When the button is clicked, it triggers a command that prints a message to the console. GUIs are all about interaction. Tkinter allows us to handle user input and events with ease. For example, we can capture the text entered in the entry field and display it back to the user. Let's modify our script to capture the text from the entry widget and display it when the button is clicked. Now, when the button is clicked, the text entered by the user in the entry field is displayed on the label. It's that simple to create interactive GUIs with Tkinter. Before we get into advanced features, let's lay the foundation by developing a basic desktop application. Imagine you're building a simple to-do list app where users can add and remove tasks. We'll start by setting up the main window and adding some basic widgets, an entry field, a list box, and buttons for adding and deleting tasks. This code creates a basic to-do list app where users can add tasks using the entry field and remove them by selecting a task from the list box. We've also added a couple of handy features like warning messages using message box when actions are invalid. Now that we have a basic app, let's improve its functionality and make it more responsive. We'll organize our code better by using classes, and we'll add features like saving tasks to a file so that they persist even after the app is closed. Refactoring our code into a class helps manage the state of our application more effectively and makes it easier to expand the app's features. By using classes, we've made our app more scalable and maintainable. You can now easily add new features, like saving tasks to a file, which we'll cover next. So, you've built an awesome desktop app, now what? It's time to package it up and share it with the world. We'll use a tool called PyInstaller to convert our Python script into an executable that can run on any machine without requiring Python to be installed. With just one command, PyInstaller or one-file todo_app.py, you can bundle your app into a single executable file. After running this command, you'll find an executable file in the dist folder. You can now distribute this file to anyone, and they'll be able to run your to-do list app on their computer without needing Python. Time series data is a sequence of data points collected at consistent intervals over time. Pandas makes it easy to work with this type of data, whether you're plotting trends or performing statistical analysis. Let's start by loading and inspecting a time series dataset. You can generate a time series dataset in Python with random data. This code reads a time series dataset and plots it. Notice how easy it is to convert the date column into a date-time format and set it as the index. Time series data can sometimes be too granular or not granular enough. Pandas offers powerful tools to resample and convert the frequency of your data, whether you need to go from daily to monthly data or fill in missing values. Resampling allows you to aggregate your data into any frequency you need. Here, we've taken daily data and resampled it to monthly averages, giving us a clearer view of long-term trends. Working with time series data often involves challenges like missing dates, irregular intervals, or time zone issues. Let's look at how Pandas can help you clean and prepare your time-based data. This code detects missing dates in the series and fills them using forward fill. This technique ensures your analysis is consistent, even when data is missing. Seaborn makes it incredibly easy to create complex visualizations with just a few lines of code. Let's start by exploring a violin plot combined with a swarm plot to visualize the distribution of data across categories. In just a few lines, we combined a violin plot with a swarm plot, giving us a detailed view of the distribution and individual data points. Seaborn's power lies in its simplicity and elegance. When preparing your visualizations for publication, it's important to fine-tune every detail. Let's customize a matplotlib plot for a polished, professional appearance. Notice how we use different fonts, labels, and layout adjustments to create a plot ready for publication. The tight_layout function ensures nothing overlaps, and saving with high DPI ensures clarity. Geographical data visualizations are increasingly important in data science. Let's use Python to create a map showing data distribution across different regions. Using GeoPandas, we can easily visualize geographical data. Here, we've highlighted Brazil on the world map, but you can adapt this to show data across multiple regions or countries. With hyperparameter tuning. Hyperparameters are settings that control the learning process of your model, and choosing the right ones can make a huge difference. We'll use GridSearch-CV from scikit-learn to find the best parameters for a support vector machine (SVM) model. With GridSearch-CV, we tested multiple combinations of hyperparameters, finding the best settings that maximize model accuracy. This saves time and ensures our model performs optimally. Cross-validation helps us avoid overfitting, ensuring our model generalizes well to unseen data. Instead of relying on a single train test split, cross-validation splits the data into multiple folds, training and testing on each fold. With cross-validation, we can see how well our model performs across different data subsets, giving us a better estimate of its true performance. Now, let's talk about ensemble methods, techniques that combine multiple models to improve accuracy. Two popular methods are random forests and gradient boosting. We'll implement a random forest model to classify the iris dataset. Random forests reduce overfitting by combining the predictions of multiple decision trees, and gradient boosting takes it a step further by focusing on improving the mistakes of previous trees. This is where deep learning gets really exciting, so let's jump right in. Deep learning frameworks like TensorFlow and PyTorch come with several built-in loss functions, but sometimes you need something custom to fit your unique problem. Let's create a custom loss function in TensorFlow errors and use it in a model. Here, we defined a custom loss function using TensorFlow operations, then used it to compile a simple neural network model. Custom loss functions give you the flexibility to tailor your model's training to your specific needs. Overfitting is a common problem in deep learning, where your model performs well on training data but poorly on unseen data. To combat this, we can use regularization techniques like dropout and batch normalization. Dropout randomly deactivates a percentage of neurons during training to prevent overfitting, while batch normalization standardizes layer inputs, improving stability and performance. These techniques are essential for building robust deep learning models. Now, let's explore sequence-to-sequence models, which are vital for tasks like machine translation and text summarization. We'll also introduce attention mechanisms, a game-changing innovation that allows models to focus on relevant parts of the input. This is a basic sequence-to-sequence model, often used for translating sequences from one domain to another, like languages. The next level is adding attention, which allows the model to focus on the most relevant parts of the input sequence. Before we can truly harness the power of text data, we need to convert words into numerical representations that models can understand. This is where word embeddings come into play. Word embeddings like Word2Vec map words into dense vector spaces where similar words are closer together. Let's create word embeddings using the GenSim library. Here, we're using the Brown corpus from NLTK to train a Word2Vec model. Once trained, this model can give us the vector representation of any word, like Python. These embeddings capture semantic meaning, enabling better performance in NLP tasks. Now, let's move on to building a text generation model using a recurrent neural network, RNN. RNNs are perfect for sequential data like text, as they can remember past information while generating new content. We'll use LSTM layers in TensorFlow's Keras to create our model. This code builds a character-level text generation model. Once trained, we can seed it with some text, and the model will generate new text based on the patterns it's learned. It's a simple but powerful demonstration of RNNs in action. Finally, let's explore named entity recognition, or NER. NER is a crucial task in NLP where we identify and classify entities like names, locations, and organizations within a text. We'll use the spaCy library, which offers a pre-trained deep learning model for NER. Here, we processed a text about Apple, acquiring a startup using spaCy's NER model. The model correctly identifies Apple as an organization and UK as a geopolitical entity. NER is incredibly useful in many applications, from information extraction to question answering. Interactive dashboards are powerful tools for turning raw data into actionable insights. Plotly Dash allows us to create beautiful, responsive, and interactive dashboards using just Python. Let's build a simple dashboard to visualize some data. In this example, we've created a simple dashboard with a drop-down menu that lets users filter data. When you select a category, the bar chart updates to reflect the relevant data. With Dash, you can easily scale this up to include multiple charts, inputs, and data sources. Once you've built a Dash app, the next step is deploying it so others can access and interact with your insights. Dash apps can be deployed on platforms like Heroku, AWS, or any web server supporting Python. Let me show you how to deploy your app to Heroku. Prepare your app for deployment. Ensure you have a procfile and requirements.txt in your project folder. The procfile should contain web python app.py. Create a Git repository. Deploy to Heroku. That's it. In just a few steps, your Dash app is live on the web, ready to share your data visualizations with the world. Dash doesn't just handle static data. You can also create live updating visualizations that reflect real-time data changes. For example, let's create a dashboard that updates every second with new data. In this example, we've set up a graph that updates every second with random data. This approach is ideal for monitoring applications, real-time analytics, and dashboards that require live data feeds. Django's templating system is powerful, and sometimes you need more than the built-in tags and filters. That's where custom template tags and filters come in. They allow you to add custom logic directly in your templates. In your Django app, create a template tags directory with an __init__.py and a custom _tags.py file. Define a custom filter. Use the filter in a template. Here, we created a simple custom filter that multiplies a value by a given argument. Custom tags and filters are great for adding reusable logic across your templates. Next, let's handle user-uploaded files. This is essential for many web applications, such as allowing users to upload profile pictures or documents. Update the model. Update the form. Update the view. Update the template. With these steps, users can upload files to your Django application, and you can easily manage them using Django's built-in file handling features. Lastly, let's implement user profiles and social authentication. Django provides excellent tools for this, and we'll use the Django Alauth package to enable login through social platforms like Google, GitHub, and more. Install Django Alauth. Update settings. Configure URLs. Create user profile. By following these steps, you can enable social authentication in your Django app, making it easier for users to sign up and log in with their favorite social accounts. Plus, you can extend the user model with additional profile fields like bios and profile pictures. Securing your Flask app with user authentication and managing user sessions is critical for any web application. Flask makes this easy with the Flask Login extension. Install Flask Login. Set up user model. Configure Flask Login. Create login and logout views. With these steps, you can authenticate users, protect routes, and manage sessions effectively in your Flask application. Next up, let's create RESTful APIs using the Flask RESTful extension. This is perfect for building scalable web services. Install Flask RESTful. Create a basic API. Add more endpoints. Here, we built a simple RESTful API that returns a greeting and allows you to fetch user data by ID. Flask RESTful streamlines the process, making it easy to create and manage API endpoints. Finally, let's add real-time communication to our Flask app using Flask Socket.io. This is excellent for chat applications, live notifications, or any feature requiring instant updates. Install Flask Socket.io. Set up Flask Socket.io. Create a simple front-end. Now, with Flask Socket.io, you can create real-time features like chat applications that allow users to interact instantly. This brings dynamic, live functionality to your web apps. SQL Alchemy is a powerful tool for managing database relationships in Python. Today, we'll explore how to define one-to-many, many-to-many, and self-referential relationships. One-to-many relationship. Many-to-many relationship. Self-referential relationship. By setting up these relationships, you can model complex database structures in your Python applications. Whether it's a hierarchical employee structure or a many-to-many relationship like books and genres, SQL Alchemy handles it all seamlessly. Next, let's look at advanced querying techniques in SQL Alchemy. We'll cover filtering, joining, and aggregating data. Filtering with multiple conditions. Performing joins. Aggregating data. Advanced querying lets you pull precisely the data you need from your database. Whether you're working with simple filters or complex joins, SQLalchemy's ORM capabilities make it straightforward. Finally, let's talk about schema migration. As your project evolves, you'll need to manage database changes without losing data. Here's where Alembic, SQLalchemy's migration tool, comes in handy. Install Alembic. Initialize Alembic in your project. Configure Alembic. Creating a migration script. Apply the migration. Alembic's auto-generate feature tracks changes in your models and creates migration scripts automatically. You can then apply these migrations to keep your database schema up to date across all environments. What exactly is reinforcement learning? Unlike supervised learning, where the model learns from a labeled dataset, reinforcement learning involves an agent that learns by interacting with its environment to maximize some notion of cumulative reward. The core idea is to figure out the best sequence of actions that leads to the highest reward. Over time, the agent gets better at making decisions that yield better outcomes. Reinforcement learning problems are often modeled as Markov decision processes, or MDPs. An MDP is defined by four components: states, the different situations the agent can be in; actions, the possible moves the agent can make; rewards, the feedback the agent receives from the environment; transition probabilities, the probability of moving from one state to another, given an action. By modeling our problem as an MDP, we can develop strategies, or policies, that help the agent choose the best actions in various states to maximize its cumulative reward. Now, let's implement a simple Q-learning algorithm. Q-learning is a reinforcement learning technique that helps the agent learn the value of taking a particular action in a particular state. The goal is to maximize the total reward over time. In this code, we simulate a very basic environment with a few states and actions. The Q-learning algorithm helps our agent learn the best action to take in each state by updating the Q values based on the rewards it receives. Over time, the agent gets better at navigating the environment to maximize its rewards. So, what's the next step after learning Q-learning? Enter Deep Q networks, or DQNs. DQNs combine the power of deep learning with reinforcement learning, allowing us to solve more complex problems, like playing video games. The idea behind DQNs is to approximate the Q-value function using a neural network. This allows the agent to handle large, complex state spaces, like those found in video games. This code sets up a basic DQN to play the cart pole game. The neural network learns to predict the Q values for different actions, allowing the agent to balance the pole effectively over time. After training, you can save the model and use it to evaluate the agent's performance. While DQNs are powerful, they're not the only game in town. Policy gradients offer an alternative by directly optimizing the policy, basically, the agent's strategy, without needing to estimate Q values. Policy gradient methods work by tweaking the policy in the direction that increases the expected reward. These methods are particularly useful in environments with continuous action spaces. This code demonstrates how to train an actor network using policy gradients. The actor directly learns the optimal policy by maximizing the expected reward for each episode. Reinforcement learning isn't just for games, it's revolutionizing many industries. From self-driving cars to financial trading algorithms, reinforcement learning is being used to solve complex, real-world problems. Imagine training an autonomous drone to navigate through a forest, or developing a trading bot that learns to maximize returns in a volatile market. The possibilities are endless. Before you start scraping a website, it's crucial to consider the ethical implications. Web scraping can be incredibly useful, but it can also be harmful if done irresponsibly. Ethical scraping means respecting the rights and resources of the website owners. Websites invest time, money, and effort into creating their content, and scraping that content without permission can strain their resources or violate their rights. Key points to cover: respect the website's content, acknowledge that the content you're scraping belongs to someone else. Always check if you're allowed to use it. Consider the impact. Repeatedly scraping large amounts of data can overwhelm a server, affecting the performance for other users. Use data responsibly. Ensure the data you collect is used in a way that doesn't harm the original content creator or violate privacy. Next up, let's talk about some of the technical and legal aspects of web scraping. Every website has its own set of rules, usually outlined in its terms of use, and sometimes enforced through a file called robots.txt. The robots.txt file is a website's way of communicating what can and cannot be accessed by web crawlers. Before you start scraping, always check this file. In this example, we're requesting the robots.txt file from a website to see what pages or sections are off limits. Always respect these instructions. Ignoring them can lead to legal issues or getting your IP blocked. Finally, let's talk about legal risks. Web scraping falls into a gray area legally, but by following some best practices, you can avoid crossing any lines. Legal issues can arise when web scraping is done without regard to the website's terms or the purpose of the scraping. To stay on the right side of the law, follow these best practices. Best practices: rate limiting. Don't overwhelm a website with requests. Implement a delay between requests to avoid hitting the server too hard. Respecting user privacy. If the data involves personal information, be extremely cautious. Make sure you're compliant with privacy laws like GDPR. Avoiding protected content. Don't scrape data behind paywalls or login forms unless you have explicit permission. By following these practices, you'll be able to scrape data responsibly, minimizing legal risks while respecting the rights of content creators. Pivot tables are an incredibly powerful tool in Pandas, allowing you to summarize and aggregate your data in ways that reveal important insights. Let's say you have a data set of sales data, and you want to see the total sales by product and region. A pivot table can help you do that with just a few lines of code. In this example, the pivot table shows the total sales for each product in the North and South regions. You can easily aggregate data based on your needs, using functions like sum, mean, and count. Key points: creating pivot tables. Use the pivot_table function to create pivot tables in Pandas. Advanced aggregation. Combine multiple aggregation functions to analyze your data more comprehensively. Next, let's talk about handling categorical data. In data analysis, it's common to encounter categorical variables. These are variables that represent categories rather than numerical values. Pandas provides several tools for working with categorical data. You can convert columns to the category data type, which can save memory and make your operations faster. By converting columns to the category type, you not only optimize memory usage, but also unlock Pandas' ability to perform specific operations on categorical data, such as reordering categories or handling missing values more efficiently. Key points: converting to categorical data type. Use the .astype category method to convert columns to the categorical data type. Advantages: discuss the memory efficiency and performance benefits of using categorical data. Finally, let's tackle the issue of outliers and anomalies in your data. Outliers can significantly skew your analysis, so it's important to know how to identify and handle them. One common way to detect outliers is by using visualizations like box plots. Once identified, you can decide whether to remove them, transform them, or analyze them separately. In this box plot, the points that fall outside the whiskers are considered outliers. Depending on your analysis goals, you might want to investigate these outliers further, remove them, or apply a transformation. Key points: identifying outliers. Use visual tools like box plots to identify outliers in your dataset. Handling outliers. Discuss strategies for dealing with outliers, such as removal, transformation, or separate analysis. Let's start with ARIMA. ARIMA, which stands for Autoregressive Integrated Moving Average, is a widely used forecasting technique. Here's how you can implement it in Python. In this plot, you can see the historical data in blue and the forecasted values in red. ARIMA is great for data with trends, but it can be complex to configure. Another powerful tool is Facebook's Profit, which is simpler to use and often yields great results with less tuning. Profit automatically handles missing data and seasonality, making it a powerful and flexible tool for time series forecasting. Next up is hypothesis testing, a fundamental technique in statistics to determine if there's enough evidence to support a specific claim about your data. Hypothesis testing involves formulating a null hypothesis and an alternative hypothesis. You then use statistical tests to determine whether to reject the null hypothesis. In this example, a t-test is used to compare the means of two independent groups. The p-value helps you determine whether the difference is statistically significant. Lastly, let's talk about A/B testing, a practical application of hypothesis testing often used in marketing, product design, and website optimization. In an A/B test, you compare two versions of something to see which one performs better. For example, you might test two versions of a landing page to see which one generates more signups. The Z-test in this example helps you determine whether the difference in conversion rates between version A and version B is statistically significant. In coding, let's make sure we have Django REST framework installed in our project. If you don't already have it, simply install it using pip install Django REST framework. Next, we need to add REST_framework to our installed_apps in settings.py. With that set up, we can now create our first API. The first step in building an API with Django REST framework is creating a model, a serializer to convert model instances into JSON, and a view to handle the HTTP requests. In this example, we've created a simple book model, a book serializer to convert book instances into JSON, and a book list view that returns all books in the database. Key points to cover: model defines the structure of the data, serializer converts model instances into JSON format, API view handles HTTP requests like GET, POST, etc. Serialization is the process of converting Python objects into JSON or other formats that can be easily transmitted over the web. Deserialization is the reverse, where incoming data is converted back into Python objects. Let's take a look at how to handle both. In this POST request handler, we take the incoming JSON data, deserialize it into a book instance, validate it, and save it to the database if it passes validation. Otherwise, we return the validation errors. Now that we have a working API, we need to secure it. DRF makes it easy to add authentication and permissions. let's start by adding token-based authentication and restricting access to certain views. First, install the simple JWT package for token-based authentication. Next, update the settings to include JWT authentication. Now, we can add authentication to our API views. In this example, we've added a permission class to ensure that only authenticated users can access the booklist view. You can easily customize these permissions based on your app's needs. So, what exactly is cloud computing? It's essentially the delivery of computing services over the internet, allowing businesses and developers to rent servers, storage, and databases instead of owning them. There are several benefits to using cloud computing, including scalability, easily scale your application up or down depending on the traffic, cost-effectiveness, pay only for the resources you use, flexibility, access to a range of tools, services, and deployment models to suit any project. Now, let's get started with AWS. If you don't have an AWS account yet, head over to aws.amazon.com and sign up for a free tier account. Once you've created your account, you can log into the AWS Management Console. This is the central place where you can access all AWS services. Let's quickly explore the console. At the top, you'll see the search bar where you can find specific services like EC2, S3, or RDS. On the left-hand side, you have the navigation panel where you can access various management tools. AWS offers tons of services, but today we'll focus on deploying a simple web app using EC2, which is AWS's virtual server offering. We'll now walk through deploying a simple web application using AWS EC2. Let's create a new EC2 instance and deploy a basic web app. Choose Ubuntu as the operating system, select the free tier eligible instance, t2.micro, allow HTTP traffic so users can access the web app, click Launch and choose an existing or create a new key pair for SSH access. Once the instance is launched, you can SSH into it by running the following command in your terminal. Replace your key.pem with the name of your key pair and your EC2 public IP with the public IP of your EC2 instance. Once logged in, you can set up a basic Python Flask web application. Basic Flask app. After creating the app, start the web server using Gunicorn. Finally, open your browser and navigate to HTTP or EC2 public IP 8000. You should see your simple Hello AWS app running. And that's how you deploy a basic Flask app on AWS. Welcome back, everyone. It's day 75 of our 100 Days of Python series, and today we're diving deeper into the world of cloud computing with advanced AWS services. We'll explore AWS Lambda for serverless functions, create a serverless API using AWS API Gateway, and learn how to scale applications with Amazon ECS and Fargate. Let's get started. First up is AWS Lambda. Lambda is a serverless compute service that lets you run code in response to events without provisioning or managing servers. Create a Lambda function in your AWS Management Console. Search for Lambda. Click on Create Function. Give your function a name. Choose the runtime. Create a new role with basic Lambda permissions. Here's a simple Python code snippet that you can use as a Lambda function to return a greeting. Once you've created your function, you can test it using the built-in test feature. Click on Test, and you should see the output in the log. Next, let's set up a serverless API using AWS API Gateway, which allows you to create, publish, and manage APIs. Step 1. Create an API. In the AWS Management Console, search for API Gateway, choose Create API, and select HTTP API. Set the API name and description. Step 2. Integrate with Lambda. Add a route, choose a Lambda function as the integration type and select the Lambda function you created earlier. You'll receive an API endpoint URL. You can test it using a browser or a tool like Postman. When you send a GET request to the endpoint, you should see the greeting from your Lambda function. Finally, let's look at scaling applications with Amazon ECS, Elastic Container Service, and Fargate, which is a serverless compute engine for containers. Step 1. Create an ECS cluster. Search for ECS in the AWS Management Console. Click on Create Cluster and choose the networking only option for a serverless environment. Step 2. Define task definitions. Click on Task Definitions and then Create New Task Definition. Choose Fargate as the launch type and define your container settings, including the Docker image, memory, and CPU. Once your task definition is set, you can run your tasks on the ECS cluster. Fargate automatically manages the underlying infrastructure, scaling up or down based on demand. First, let's understand what big data is. Big data refers to extremely large datasets that cannot be easily managed or processed by traditional data processing tools. The key characteristics of big data are often described by the 3 V's. Volume. The amount of data being generated is massive, often in terabytes or petabytes. Velocity. Data is generated at high speeds and needs to be processed quickly. Variety. Data comes in various formats, including structured, semi-structured, and unstructured. To handle big data, we need distributed computing, which allows data to be processed across multiple machines, enabling faster processing and analysis. Now, let's talk about Apache Spark. Spark is an open-source distributed computing system that provides an interface for programming entire clusters with implicit data parallelism and fault tolerance. Here are the main components of Apache Spark. Spark Core, the foundation of the Spark framework, responsible for basic functionalities like task scheduling and memory management. Spark SQL allows querying structured data using SQL or Data Frame API. Spark Streaming enables real-time data processing. MLib, a library for machine learning on Spark. GraphX, for graph processing and analytics. Now, let's get our hands dirty with some code using PySpark, the Python API for Apache Spark. First, ensure that you have PySpark installed. You can do this by running the following command in your terminal. Next, let's create a Spark session. This is the entry point for working with Spark. For this example, let's assume we have a CSV file named data.csv. We can load this data into a Spark data frame. Now that we have our data loaded, let's perform some basic analysis. Before we get into the hands-on part, let's understand the concept of data streaming and why it's so important. Data streaming refers to the continuous, real-time transmission of data from various sources. This is crucial for scenarios where data is generated rapidly and must be processed instantly, such as stock market monitoring, social media feeds, or real-time analytics. In contrast to traditional batch processing, where data is collected and processed in chunks, real-time processing allows for immediate analysis and decision-making as data flows in. Now, let's talk about Apache Kafka. Kafka is an open-source, distributed event streaming platform. It's widely used for building real-time data pipelines and streaming applications. Kafka allows you to publish and subscribe to streams of records, much like a message queue system. Before we start, make sure you have Kafka installed and running on your local machine or server. You can download it from the official Apache Kafka website. Once Kafka is installed, start the Zookeeper and Kafka servers. Use the following commands in your terminal. Kafka streams data into topics, which are essentially data feeds. Let's create a new topic for our streaming data. Now that our Kafka server is running and we have a topic set up, let's move on to Spark Streaming. Spark Streaming allows us to process real-time data streams using the Spark framework. First, you need to create a Spark Streaming context. Make sure you have PySpark installed. Next, let's write some Python code to process our streaming data from Kafka using Spark Streaming. Now, let's run the script. It will connect to Kafka and start streaming data from the test topic. You'll see the data being printed in real time. World of containerization using Docker. We'll explore how to package your Python applications into containers so that they can run consistently across any environment. Let's get started. Before we get hands-on, let's first understand the concept of containerization. Containerization allows you to package your application and its dependencies into a lightweight, isolated container that can run uniformly in any environment, whether it's your local machine, a server, or the cloud. And for this, we use Docker, which is a platform designed to simplify containerization. Docker allows you to create, manage, and deploy containers efficiently. If you don't have Docker installed yet, head over to docker.com and download it for your operating system. Once installed, make sure Docker is running by executing this command in your terminal. You should see the Docker version output if it's properly installed. Now, let's dive into creating and running containers. Containers are essentially instances of Docker images. These images are like blueprints that contain your application and its environment. First, we need to create a Docker file, which defines what will be inside our container. Let's start with a simple Python app. Now, let's create a Docker file in the same directory as our app.py file. With our Docker file ready, let's build the Docker image. Run the following command in the terminal. This command builds an image using the instructions in the Docker file and tags it as MyPythonApp. Now that we've built the image, we can run the container using this command. You should see Hello, Docker printed in the terminal. This is your Python app running inside a Docker container. Now that you understand how to create and run containers, let's Dockerize a slightly more complex Python application. We'll create a Flask app and run it inside a Docker container. Create a simple Flask app. Next, let's create a Docker file for our Flask app. Don't forget to create a requirements.txt file for Flask. Now, we'll build and run our Flask application in Docker. Visit http localhost 5000 in your browser, and you should see the Hello, Dockerized Flask app message. And that's it. Today, we covered the basics of Docker and containerization, created and ran simple Docker containers, and even Dockerized a Python Flask application. Containerization is a powerful skill that will simplify the deployment process and ensure that your applications run seamlessly in any environment. If you enjoyed this tutorial, make sure to like, subscribe, and hit the bell icon for notifications. See you tomorrow.